Case study: deploying AI-driven intrusion detection systems, a case study on mitigating sophisticated cyber threats at TechCorp. The early hours of dawn saw the IT team at TechCorp scrambling to address a sudden spike in network activity. The anomaly began at 3 a.m., with data packets flooding the system at an unprecedented rate. This unexpected surge triggered alarms in the company's network-based intrusion detection system, a sophisticated piece of technology that served as the sentinel of the company's cybersecurity perimeter. The team, led by senior analyst Lisa, knew the stakes were high. TechCorp had been the target of cyber threats before, but the current scenario seemed to suggest something more sinister, possibly a distributed denial-of-service attack. To understand the core of the issue, Lisa initiated a detailed analysis of the network traffic logs. The NIDE had flagged several IP addresses originating from disparate global locations. These addresses had shown abnormal behavior patterns consistent with DDoS attack signatures. The first question Lisa pondered was, what specific patterns or anomalies should the team prioritize in their investigation to confirm the nature of the attack? As the team dove deeper into the logs, they noticed repetitive connection requests to the company's main servers, far exceeding normal thresholds. This led Lisa to task her colleague, Mark, with deploying a secondary line of defense, the host-based intrusion detection systems on critical servers. Unlike NIDES, which monitored the overall network traffic, HIDES provided granular insights by scrutinizing local system activities, logs, and user behaviors directly on the servers. This dual approach was pivotal. While NIDES offered a broad view of network anomalies, HIDS could reveal internal irregularities that might have gone unnoticed. However, merely identifying the attack was not enough. Lisa knew the next critical question: how can the integration of AI and machine learning algorithms bolster the detection capability of both NETs and HETs to differentiate between false positives and actual threats? With cyber threats evolving rapidly, AI-driven IDS were proving instrumental. Traditional IDS systems operated on predefined signatures of known threats, which, although effective, were limited in dealing with novel attack patterns. AI algorithms, particularly those based on machine learning, trained on vast datasets of network traffic and system logs, could detect subtle, previously unknown anomalies. The team initiated an AI-driven anomaly detection model employing deep learning techniques. This model analyzed historical data to create a baseline of normal network behavior. Any deviation from this baseline was flagged for further scrutiny. The real test came when the system detected a new pattern that did not match any known signature but exhibited unusual characteristics. The pattern was flagged by a deep learning model trained to recognize hierarchical data representations. One pressing question that emerged was, what are the implications of relying on AI-driven IDS in terms of data quality and diversity, and how can the team ensure the dataset used for training is both comprehensive and unbiased? The quality and diversity of training data were paramount. Inaccurate or biased datasets could lead to false positives, wasting resources, or worse, missing actual threats. Hence, the team needed to continuously update and diversify their datasets, incorporating insights from different network environments and threat landscapes. As TechCorp's AI-enhanced IDS flagged potential threats, the system not only issued alerts, but also initiated automated response actions. Malicious IP addresses were blocked and suspicious processes were terminated. This rapid response was crucial in mitigating the attack's impact. Concurrently, the HICs provided valuable log data for post-incident analysis. The team now faced another critical question. How can IDS logs and alerts be leveraged effectively for incident response and forensic analysis to improve future defenses? The incident response protocol was activated. Automated scripts isolated compromised systems, preventing lateral movement by the attacker. The detailed logs from the IDS provided the forensics team with a wealth of information to analyze the attack's nature and scope. They identified vulnerabilities that had been exploited, allowing the team to patch these gaps and fortify their defenses. However, another challenge presented itself. The interpretability of the AI models used in the IDS was a concern. Deep learning models, while highly accurate, often functioned as black boxes, making it difficult to understand their decision-making processes. Lisa posed an important question to her team. How can the interpretability of AI models be improved to ensure trust and facilitate human oversight in cybersecurity operations? To address this, the team implemented techniques to make AI decisions more transparent. They used model explainability tools that provided insights into how the AI arrived at specific conclusions. This transparency was vital for building trust among the cybersecurity team and ensuring that human analysts could oversee and validate the AI's decisions. Despite their best efforts, the team knew that the nature of cyber threats was constantly evolving. Adversaries were always developing new strategies to bypass detection. Therefore, the next question was, what ongoing research and collaborative efforts are necessary to keep AI-driven IDS effective against emerging threats? The answer lay in continuous collaboration between academia, industry, and the cybersecurity community. By sharing knowledge and staying abreast of the latest research, TechCorp could ensure their IDS remained adaptive and resilient. In conclusion, the incident at TechCorp underscored the critical role of intrusion detection systems in modern cybersecurity strategies. The complementary strengths of NITES and HDDs provided a robust framework for network and host-level monitoring. The integration of AI and machine learning significantly enhanced the detection capabilities, allowing the team to identify and respond to sophisticated threats efficiently. However, the incident also highlighted the importance of high-quality training data, model interpretability, and ongoing collaboration to stay ahead of evolving cyber threats. By reflecting on these thought-provoking questions and analyzing the solutions, students can better understand the complexities of implementing and managing IDS in real-world scenarios. They can appreciate the synergy between human expertise and AI-driven automation in creating a proactive security posture. As the cybersecurity landscape continues to evolve, the lessons from TechCorp's experience will be invaluable in preparing the next generation of cybersecurity professionals.